for a moment. Unpleasant, isn't it? Now listen again. Same speakers, same sound, only the intent has changed. So did the meaning and the emotion you felt. If I would ask you to imagine art, you would probably think of a painting in a gallery, or a sculpture in stone, or maybe even a dancer on stage. I believe most of you here wouldn't think of a phone screen, game controller, a line of code. Well, what if I told you that the most powerful brush humanity has ever invented is already in your pockets right now? When you were a child, you used to play with crayons and drew, or with a wooden xylophone and created music, or maybe even created toy houses with blocks. That first-time experience, that was pure art. Somewhere along the way, adults forget that. They start to believe that art belongs in museums, in galleries, in stages. They believe that art is for the elite. It's for someone that's creative, but it's not. Art was never supposed to be exclusive. Art is first and foremost a method of expression. For centuries, it was easy to recognize art. They did live in museums and galleries, on stages, in sculptures. But what about technology? Technology is just a tool, right? Something that's cold and functional, nowhere near art. Webster's dictionary says, art is a conscious use of skill and creative imagination, especially in creating aesthetic objects. But here's a simpler version for you. Art is an intentional craft that moves humans. Intentional, as in we create with purpose. Craft, as in we use skill to shape materials. And moves humans, as in, well, someone feels something. But what do technologists do? They shape code. It's a different type of material, but the idea is kind of the same. You want to make someone feel something. If paint is pigment on canvas, then technology would be behavior on canvas. My professional background is in computer science. I deal with logic, numbers, and code, and sometimes people. But over the past decade, I realized that programming doesn't necessarily have to be serious. It can be sometimes just art. Sounds bizarre, right? Let me introduce you to esoteric programming languages, or ESOLangs for short. ESOLang is a computer programming language designed to be weird, designed for experimentation, designed to be hard to read, hard to write, and sometimes even as a joke. They're funny, they're amazing, they're new, and again, sometimes they can be even hilarious. This is brainfuck. It's an esoteric programming language built with only 8 symbols. Yes, this is a fully functional program. Very obscure to read, yet it still exists. And this is Chef, a programming language, an ESOLang, that makes your code look like a recipe. And it is a functional code. But it's not edible, right? Or is it? There's a famous chef code which is also a chocolate cake. So if you decide to make it, you can actually taste a beautiful chocolate cake. Or you can use the same code and compile it. And there are some output that you can expect. Or how about Piet, named after the famous artist Piet Mondrian, where code is not written with words, but rather with colors. These are 6 examples of different artistic paintings built in Piet. This is code, yet this also looks like art. Incidentally, these 6 images, though distinctively different, when ran through Piet as a code compiler, they all output the same thing. They say, "Hello, world," a famous sentence programmers use when trying a new language or trying to produce something new, as in art or programming. Or how about this one? This is called whitespace. It's a programming language designed entirely out of spaces, new lines, and tabs. Can you see it? No? Oh, obviously you can't see this masterpiece because it's all spaces. It doesn't have words, not even colors, and the background is white. So let me help you for a second. How about now? I've selected the code so you can see it now, yet it's still pretty much unreadable. ESLings challenge what technology can be. They design for programmers to be creatives and artists again, to be curious, to explore, and to be amazed. And more importantly, they remind us that technology can make us feel, not just function. Remember the example from the beginning of this talk? Remember how the meaning changed when we changed the intent. So when we introduced intent to the system, the outcome has changed. This is what ESLings do. They take absurdity, chaos, and turn it into creativity, something meaningful, something that moves, hopefully, many of you. But all of these examples are examples of, not of utility, but of creativity, right? They ask the simple question, can we produce something that's not just solving a problem, but expressing an idea, something that's more creative than just creating a computer program? ESLings turn instruction code into art or interpretation. But if you want to see the prime example of programming as art, then you need to meet the Quine. A Quine is a computer program that outputs its own source code. It doesn't copy it, it doesn't read it from a file, it recreates it, line by line, symbol by symbol. If you run a Quine program, the output is identical to the input that you've written. It's like words would turn around and read themselves out loud back. This is another example of a Quine, this one I think in Ruby, that even has the name of the author spelled out inside the code. Now, if you've seen these 3 slides, you're probably confused and you have no idea what you just saw. And that's okay. It's not a painting, it's not sculpture, it's computer art. It's made to be different. But here's one more example. Coup de grace, if you like, between computer programming and specifically Quines. This is called a Quine relay. It's a computer program built in Ruby that you can compile, and the output will be code, again, but in a different language. And that code can be compiled again, and it will produce another piece of code in another language, and so on and so on. 128 times this process repeats until it reaches back the original code written in Ruby. You can try this for yourself. This is an open source project you can find online, and maybe you can even build your own Quine. Because when we build, whether it's a startup, an app, or an ESOLang that has no purpose, we're not just solving problems, we're expressing ideas. We're creating and imagining something new. And because of that experience that we feel, because of each individual that tries this, we are better as humans. We are closer to art in the way that art was imagined. But we have to think of the classic definition of art. That was the bridge between emotion and form. Digital art and technology is just an extension to that bridge. Imagination gives us opportunity to write with color. And each individual color has meaning, it has representation. So the next time you write a function, design an interface, or debug a bug, you're not just building systems, you're not just solving problems, you're creating experiences. Just like the first time you banged on a wooden xylophone or drew with crayons. And remember, you're composing symphonies of logic. You are painting with electrons. You are creating art beyond what was art initially imagined. Thank you.